Good day everyone, I am Claire Bisira and I will just continue the discussion about the Fermat-Kraitchik factorization method. So, Fermat's method is most effective when the two factors of n are of nearly the same magnitude. For n, this case a suitable square will appear quickly. So, this means po that this method is particularly useful for factoring large numbers that are the product of two primes close in value. So, to illustrate po, let us suppose that n is equals to 23,449 is to be factored. So, the smallest square exceeding n is 154 squared, so that the square k squared minus n starts with 154 squared minus 23,449 is equals to 23,716 minus 23,449. 23,716 minus 23,449 is equals to 267, which is not a perfect square. Kaya po, ang gagamitin naman natin ay ang k squared plus 1 minus n. Kaya po naging 154 plus 1 squared is 155 squared. Then, ima-minus po ulit natin sa n. Kaya magiging 155 squared minus 23,449 is equals to 24,025 minus 23,449 is equals to 576. Then, ang 576 po is a perfect square which is equal to 24 squared. Hence, factors of 23,449 are, so alam naman po natin na ang factor ng n is equals to x squared minus y squared ay n is equals to x plus y times x minus y. So, ang n po natin ay 23,449 and then ang x squared po natin ay 155 squared. And yung y squared po natin ay 24 squared. Kaya magiging 23,449 is equals to 155 plus 24 times 155 minus 24. And then 155 plus 24 is equals to 179. And 155 minus 24 is equals to 131. 179 times 131 is equals to 23,449. That is equals to n, which is 23,449. When examining the differences k squared minus n as possible squares, many values can be immediately lately excluded by inspection of the final digits. We know, for instance, that a square must end in one of the 6 digits, 0, 1, 4, 5, 6, and 9. So, by calculating the squares of the integers from 0 to 99 modulo 100, we see further that for a square, the last 2 digits are limited to the following 22 possibilities, which are 00, 01, 04, 09, 16, 21, 24, 25, 29, 36, 41, 64, 69, 76, 81, 84, 89, and 96. So, malalaman daw po natin na perfect square po ang large numbers kapag nag-e-end ito sa 0, 1, 4, 5, 6, and 9. And pagdating naman sa pag-calculate ng integers from 0 to 99, modulo 100, malalaman lang natin na perfect square ang large numbers kapag ang last 2 digits ay nag-e-end sa nakikita nyong 22 possibilities. There is a generalization of Fermat's factorization method that has been used with some success. Here, we look for distinct integers x and y such that x squared minus y squared is a multiple of n rather than n itself. that is x squared is congruent to y squared modulo n. Having obtained such integers, d is equals to GCD of x minus y modulo n, or d is equals to GCD of x plus y modulo n, can be calculated by means of the Euclidean algorithm. This method is particularly useful for factoring large composite numbers efficiently. By finding the greatest common divisor of x minus y modulo n or x plus y modulo n, we can determine a non-trivial factor of n. For example, suppose we wish to factor the positive integer n is equals to 2,189 and happen to notice that 579 squared is congruent to 18 squared modulo 2,189. Then we compute using the Euclidean algorithm. 2,189 divided by 561 is equals to 3, and ang remainder is 506. Then 561 divided by 506 is 1, and the remainder is 55. Then 506 divided by 55 is equals to 9, the remainder is 11, and then 55 divided by 11 is 5. So, kapag ginamit natin ang GCD of x minus y modulo n, meron tayong GCD of 579 minus 18 modulo 2,189, and then 579 minus 18 is equals to 561. Then the GCD of 561 and 2,189 is 11. Kaya, nakuha natin ang 11, which is the prime divisor of 2,189. So, kanina, ginamit natin yung GCD of x minus y modulo n. Ngayon naman, ang gagamitin natin ay GCD of x plus y modulo n. Kaya meron na tayong GCD of 579 plus 18 modulo 2,189. And then 579 plus 18 is equals to 597, and the GCD of 597 and 2,189 is equals to 199. So siguro nagtataka kayo kung paano tayo nag-arrive sa 579 whose square modulo 2,189 and also turns out to be a perfect square. Kasi po, in looking for squares close to multiples of 2,189, it was observed that 81 squared minus 3 times 2,189 is equals to negative 6. And 155 squared minus 11 times 2,189 is equals to negative 54. So, siguro nagtataka kayo kung saan galing yung 3 and negative 6. So, kapag kinompute natin ang 81 squared divided by 2,189, ang makukuha natin ay 2.99. I-round off natin kaya naging 3. And then, i-multiply natin ang 3 times 2,189, makukuha natin ay 6,567. I-subtract natin siya sa 81 squared, ang makukuha natin ay negative 6. Ganon din sa 155 squared, i-divide natin siya sa 2,189, ang makukuha nating sagot ay 10.97. I-round off ulit natin, kaya ang nakuha na natin ay 11. And then, i-multiply natin ang 11 times 2,189. Ang makukuha natin ay 24,079. I-subtract natin siya sa 155 squared. Ang makukuha natin sagot ay negative 54. Which translate into 81 squared is congruent to negative 2 times 3 modulo 2,189. And 155 squared is congruent to negative 2 times 3 over 3. Modulo 2,189. When these congruences are multiplied, they produce 81 times 155 squared is congruent to 2 times 3 times 3 over 2. modulo 2,189 because the product of 81 times 155 is equals to 12,555 is congruent to negative 579 modulo 2,189. We ended up with the congruence 579 squared is congruent to 18 squared modulo 2,189. Kasi kapag divide natin ang 81 times 155 squared sa 2,189, we will get the remainder of 324, which is the same kapag divide din natin ang 2,189 sa 18 squared, which is makukuha din natin ang remainder na 324. Kaya nasabi natin na 579 squared is congruent to 18 squared modulo 2,189.